what I want to do in this video is re-simplify this expression 3 times the principal root of 500 times x to the third, and take into consideration some of the comments that we got out on YouTube that actually give some interesting perspective on how you can simplify this. So just as a quick review of what we did in the last video, we said that this is the same thing as 3 times the principal root of 500. And I'm going to do it a little bit different than I did in the last video, just to make it interesting. This is 3 times the principal root of 500 times the principal root of x to the third. And 500, we can rewrite it, because 500 is not a perfect square. We can rewrite 500 as 100 times 5, or even better, we can rewrite that as 10 squared times 5. 10 squared is the same thing as 100. So we can rewrite this first part over here as 3 times the principal root of 10 squared times 5 times the principal root of x squared times x. That's the same thing as x to the third. Now, the one thing I'm going to do here, actually, I won't talk about it just yet, of how we're going to do it differently than we did in the last video. This radical right here can be rewritten as, so this is going to be 3 times the square root, or the principal root, I should say, of 10 squared times the square root of 5. If we take the square root of the product of two things, it's the same thing as taking the square root of each of them and then taking the product. And so and this over here is going to be times the square root of, or the principal root of x squared times the principal root of x. And the principal root of 10 squared is 10. And then what I said in the last video is that the principal root of x squared is going to be the absolute value of x, just in case x itself is a negative number. And so then if you simplify all of this, you get 3 times 10, which is 30, times, and I'm just going to switch the order here, times the absolute value of x. And then you have the square root of 5, or the principal root of 5, times the principal root of x. And this is just going to be equal to the principal root of 5x. Taking the square root of something and multiplying that times the square root of something else is the same thing as just taking the square root of 5x. So all of this simplified down to 30 times the absolute value of x times the principal root of 5x. And this is what we got in the last video. And the interesting thing here is, if we assume we're only dealing with real numbers, the domain of x right over here, the x's that will make this expression defined in the real numbers, then x has to be greater than or equal to 0. So maybe I could write it this way. The domain here is that x is any real number greater than or equal to 0. And the reason why I say that is if you put a negative number in here, and you cube it, you're going to get another negative number. And then it doesn't make at least in the real numbers, you won't get an actual value. You'll get a square root of a negative number here. So if you assume this right here, we're dealing with the real numbers. We're not dealing with any complex numbers. When you open up the complex numbers, then you can expand the domain more broadly. But if you're dealing with real numbers, you can say that x is going to be greater than or equal to 0. And then the absolute value of x is just going to be x, because it's not going to be a negative number. And so if we're assuming that the domain of x is, or if this expression is going to be evaluable, or it's going to have a positive number, then this can be written as 30x times the square root of 5x. If you had the situation where we were dealing with complex numbers, then you would. So numbers that were, and if you don't know what a complex number is or an imaginary number, don't worry too much about it. But if you were dealing with those, then you would have to keep the absolute value of x there, because then this would be defined. This would be defined for numbers that are less than 0.